Let's sketch the transformations. G of x equals the absolute value of 2x. H of x equals 2 times the absolute value of x minus 3. And I of x equals negative 2 times the absolute value of x plus 2 minus 1 of the standard absolute value function f of x equals the absolute value of x. Recall that the graph of the standard absolute value function looks like this. This is the graph of the function x, and the graph of the absolute value of x makes all the negative outputs positive outputs. So the negative part of the line reflects about the x-axis. What about g of x equals the absolute value of 2x? We see that the x's are doubled. So when we plug in a 1, we get a 2 as an output. When we plug in a 2, we get a 4 as an output, because 2 times 2 is 4. And for negative 1 and for negative 2, we also get 2 and 4 as an output, because the absolute value makes a positive out of a negative. So we see a coefficient greater than 1 stretches the graph of the absolute value function. How can we sketch 2 times the absolute value of x minus 3? Let's plug in some x values to see what y values we get. 0 minus 3 is negative 3, and the absolute value of negative 3 is 3. 2 times 3 is 6. So 0, 6 is a point on the graph. Let's plug in a 1 and see what we get. 1 minus 3 is negative 2, and the absolute value of negative 2 is 2. 2 times 2 is 4. So 1, 4 is also a point on the graph. Let's try 3. 3 minus 3 is 0, and the absolute value of 0 is 0. 2 times 0 is 0. So 3, 0 is a point on the graph. Let's try 4. 4 minus 3 is 1, and the absolute value of 1 is 1. 2 times 1 is 2, so 4, 2 is also a point on the graph. And we already see what the graph looks like. As we learned in our previous videos, the negative 3 shifts the graph to the right. And the 2 in front of the absolute value stretches the graph. Let's look at the last transformation. We already see that the negative sign will reflect the graph about the x-axis. And the 2 will stretch the graph. But what about the negative 1? Let's see. The best way, if you are not sure, is to plug in some x values and see what y values you get, like we did in the previous example. Let's start with 0. 0 plus 2 is 2, and the absolute value of 2 is 2. 2 times negative 2 is negative 4, minus 1 is negative 5. Negative 1 plus 2 is 1, and the absolute value of 1 is 1. 1 times negative 2 is negative 2, minus 1 is negative 3. Negative 2 plus 2 is 0, and the absolute value of 0 is 0. 0 times negative 2 is 0, minus 1 is negative 1. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1, times negative 2 is negative 2. Minus 1 is negative 3. We see that the negative 1 shifts the graph 1 unit down. Does this look familiar? Yes, this is exactly the same behavior we see with parabolas. The 2 is the horizontal translation, and the 1 is the vertical translation. And the number in front of the absolute value stretches or compresses the graph. More to come, so stay tuned.